Hello students, my name is Dr. P. Selvarangan. I am Assistant Professor in the Department of Physics, Kalasalingam Academy of Research and Education. Now we are going to do laser particle size determination. Aim of the experiment, we are going to determine the particle size by using laser. The apparatus required are, we need the laser source. It's a helium neon laser, it's a gas laser, and we need a lycopodium powder. So you see here, there's a glass plate here. In the glass between the, actually there are two glass plates are here. So between the two glass plate, we have sprayed that lycopodium powder. Okay, so we know that powder means it's a mixture of particles, right? So we are going to find out the particle size. The two glass plates are fixed here, and we have a stand to hold this glass plate, and we need a screen, and to measure take the readings, we have a meter scale and another scale also be here. Okay, so there are two readings we have to take. One is we want to measure the distance between the screen and the stand. That means the glass plate and the screen. We can keep it like this. And now we switch on the laser. You see here, so we know that the particle, this powder is a lycopodium powder. So here from the laser, this laser source, when it passes through that glass plate, because of that particle, okay, it gets diffracted. Okay, so now in that screen, we are getting the diffraction pattern. So this is circles like that. Now this is the 0th order, the center one is 0th order, and this one first order, this is second order. So now we have to take two readings we have to note down. One is the distance between this screen and the glass plate, the distance we have to note down, that is called D1, and then this order, the distance between the first order to the 0th order, the distance we have to note down. Similarly, the second order to 0th order distance we have to note down, and we have to take the reading, then we can do the calculation. We have the formula D equal to lambda into m into square root of d1 square plus ym square divided by ym. Here d1 is the distance between the screen and the glass plate, and lambda is the wavelength of the laser. That value is 6328 Armstrong 10 power minus 10 meter. That is the wavelength of the laser, and then this the distance of the spectrum. Okay, we have to note down. Okay, the distance we have to fix. Okay, the distance maybe we can fix around 5 centimeter at least minimum, or 6 centimeter. Right hand side and as well as left hand side. So we have to take two readings. By using a small scale like this, by using this one, we can take the readings. We have to fix like this and take the reading on both sides. Then after taking reading, then slightly we move the screen bit further from this glass plate. Maybe let us say 7 centimeter. Okay, we can fix it like this, 7 centimeter. Then again repeat the same. That is, we have to take the second reading. That is that reading is called ym. Okay, so that is from 0th order to first order, similar 0th order to second order. Like that on both sides, left hand side, right hand side, we have to take the second reading. Then again slightly move, we move this screen away from this glass plate. Let us fix it at 8 centimeter. That is the distance between the glass plate and the screen. It's 8 centimeter. Then repeat again. We have to take the reading, the ym reading, and the order of spectrum. That is from the 0th order to first order, the distance we have to note down. From 0th order to second order, we have to note down on the right hand side as well as left hand side. Finally, taking all the readings, then we can do the calculation by using the formula D equal to lambda into m into square root of d1 square plus ym square divided by ym. The wavelength of given laser source is 6328 Armstrong unit, and we know that 1 Armstrong unit equal to 10 power minus 10 meter. So, it will be 6328 into 10 power minus 10 meter. Now, first we are going to fix the distance between glass plate and the particle, that is 6 centimeter. Now, we have to measure the first order, that is 0th order to first order distance we have to measure, and left hand side it will be, we have 0.5 centimeter. Similarly, on right hand side also we will get the same, that will be 0.5 centimeter, and we have to take the mean value of these two and get it will be 0.5. Then we have to take the square of that value, that is ym square, it will be 0.25, and similarly then d1, the d1 is the distance between particle and the screen, that is d1, and the square of that value, it will be actually that distance will be 6 centimeter. Now, the square of that value is 36, okay, into 10 power minus 4 meter. If you convert that one to meter, it will be 36 into 10 power minus 4 meter. Then we have to take the square root. We have to add these two values, that is ym square plus d1 square, and we have to take the square root of that. It will be 6.0208. Then substituting these values in that formula, that is the size of the particle d equal to lambda into m into square root of d1 square plus ym square divided by ym. Then substituting the value lambda value 6328 in 10 power minus 10, m is the order of spectrum. So, first reading it will be first order, m equal to 1. Then from the table we have that square root of ym square plus d1 square, that value is here, it is 6.0208. Then substituting that value in that formula, then divided by ym value, the mean ym value we have for the first reading, it is 0.5. Substituting that, then finally we can get the value 76199.24 into 10 power minus 10 meter. Then moving the power on the left hand side, that is 7.61992 10 power minus 6 meter, and we know that this 10 power minus 6 meter equal to 1 micrometer. So, that is 76199.24 to 10 power minus 10 meter, and if we move the decimal on the left hand side, it will be 7.61992 into 10 power minus 6 meter, and we know that 10 power minus 6 meter equal to 1 micrometer. So, that value answer will be 7.61992 micrometer. Then similarly second reading, that is second order, the distance between 0th order to second order. Left hand side we got 1 centimeter, right hand side also we got 1 centimeter. Then adding these two we get one ym value is 1 centimeter only, then square of that value 1, and d1 square. So, d1 is 6 centimeter and square of that is 36 into 10 power minus 4. Now, we have to add these two values, ym square value plus d1 square, and adding these two and take the square root, we will get 6.0828. Then substituting this one again in that formula, that is now here, please remember it is a second order. So, m value is equal to 2, m equal to 2. So, d1 6 into 10 power minus 2 meter, ym 1 into 10 power minus 2 meter, and m order of spectrum m equal to 2. Now, in that substitute all these values in that formula, we will get 7.69839 into 10 power minus 6 meter, that is 7.69839 micrometer. So, for the second reading 7 centimeter, the first order, for the first order we can get 7.40977, that is the 977 micrometer, that is the particle size value. For second order we got 7.49034. Similarly, for 8 centimeter, for first order we can get 7.25966 micrometer, and second order we can get 7.34193 micrometer. Then finally, after taking all the readings, all the particle size values. Then finally we have to take the mean value, that is we have to add all the 6 values here. All the 6 values we have to add, then divided by 6, that is the mean value. That value, that the mean particle size d value equal to 7.47 into 10 power minus 6 meter, that is 7.47 micrometer. So, the particle size of a given lycopodium powder is 7.47 micrometer. Okay, so from this experiment we can able to determine the size of the particle in a powder. Similarly, if you want to measure the particle size for any other powders, so that we can able to find out. Like that, in using laser we can able to find out, we can able to determine the wavelength of the laser and other properties. For example, if we want to measure the characteristics of a fiber. Okay, so in that case also we can use the laser. Okay, so from this experiment we can able to determine the size of the particle. Okay, so similarly the laser has many applications. For example, as I told you earlier, it can be used in telecommunication applications. Okay, so in particularly optical fiber communications, laser can be used as a source, and also for medical applications and industrial applications, plenty of industrial applications also be there. Okay, thank you students. We will meet in another experiment.